Hello everyone, our today's topic is the practical statistics. So, we will not go in detail of the statistics, we will confine ourselves here our discussion only with some practical application of statistics in textile industry or textile practices. And most commonly used practical or statistical approaches are, one is test of significance and control charts. Okay. These two aspects we will cover here. So, first let us try to understand the distribution. In textile industry, in mill practice, we have to handle large number of data, large number of items we have to test. Suppose these are the data, it has been tested for strength, okay. Unit may be anything. Okay. So, 110 to 115. So, the strength varies from 110 to 170. So, 110 to 115. So, the frequency is that number of samples we have got, say 2, 116 to 120, another 2, like that. So, we can form a table. This table, if we form in the form of diagram, this is the distribution, and in most of the cases in textile material, as they are in random in nature. So, most of the cases it has been observed the distributions are normal distributions. So, what is normal distribution? This normal distribution is that symmetrical about the central value. So, this is the central value and both the sides with these are symmetrical. There are cases it is asymmetrical distribution, like we have discussed the length biased sampling, where it is skewed towards the higher side, but in our discussion we will confine ourselves that most of the distributions are in normal distribution. So, the nature, what is the nature? This is the at the center where the central value is actually coinciding. That means, this is the mean, this is the median and this is mode with the maximum frequency. So, maximum frequency is at the center. Okay. If we say the number of data of the left side of this line, central line, and right side of the central line are almost same. That means, it is becoming median, and also if we take the average value, this will be the same. That is why this in normal distribution the central line it is coinciding for mean, median, mode. Now, we will with this assumption we will try to see what is there in the normal distribution. Now, if we see this is the this sigma is the standard deviation, and plus minus 1 sigma, what does it mean? That is mean plus 1 sigma and minus 1 sigma. So, if we see this is the mean value it is a mu, okay, and plus 1 sigma, if we go right side, this is the plus side, and then if we go to the minus side, in normal distribution typically it is around 34%. If we go in one side, this is typically the 34% of the data 34% of the entire data lies on the that mean plus 1 sigma, and similarly minus 1 sigma it is another 34%. So, if you take together it is a blue line, blue zone, this takes care of about approximately 68% of the data. Now, if you take the larger value, so plus minus 2 sigma, if we see plus minus 2 sigma, so from plus 1 sigma to plus 2 sigma, say plus 1 sigma, you will see that it is a 34% data, and plus 2 sigma it has become 13.6% approximately, that because it is a this is the it is going away from the mean zone. So, at the right side we are adding 13.6% and again in the left side we are adding 13 points, because it is equal in the both sides. So, if you take together all this plus 2 sigma and minus 2 sigma, it is taking care of 95% of the data. That means, here within the 90, if it is plus minus 2 mu plus minus 2 sigma, that means 95% of the data are lying in that region. And similarly, one can have plus minus 3 sigma, it is almost 99.9% in that way. So, if we see plus minus 2 sigma, it is 95% of the data are included in this, that means 5% of the data are above that range, beyond this side. So, in one side it has become 2.5% approximately. So, one side it is 2.5% data, it is larger size, and smaller zone it is another 2.5%. The total it has become 5% data fall outside this range. Okay. Now, so in one side it is a 2.5%. What does it mean 2.5%? So, that means 1 in every 40 data is ranging its larger size. That means, if we take say reading of 40 yarn count, and if we assume it is a normal distribution, that means 1 in 40 readings will be equal, will be more than mean value plus 2 of standard deviation. Okay. That is, suppose a mean value is say 10, standard deviation is say 1, that means 10 plus 2 multiplied by 1, that means 12. So, 1 out of 40 readings will be more than 12. Similarly, 1 out of 40 readings will be less than 8. So, that is the concept of this. Okay. And if we are talking about the plus minus 2 sigma. Now, as we have discussed earlier also, so let us see, try to see once again what is population and what is sample. Population is the whole bulk of the material available for testing. So, for testing, suppose as we have discussed, in a consignment, when it is coming for to a particular customer, and a lot, a particular lot, whatever number of samples are bobbins are there, these are called population, and sample is a relatively small fraction of that population. So, we take small fraction as we have discussed earlier. So, most of the time testing of whole population is not possible. So, the population characteristics are normally assessed from sample analysis. Now, we have discussed the sample and we have discussed the sampling technique earlier. Now, we have got sample, suppose out of say 1000 bobbin, we have selected randomly, whatever way we have selected say 10 bobbins. Now, from 10 bobbins, can we tell whatever analysis we do, mean, whatever standard deviation, whatever statistical analysis do, can we assess can we tell that the population mean is like this same mean? We cannot tell, but it is not possible, but we can actually guess the characteristics of the population by assessing the sample. Now, there will be some confidence. Suppose if we test 10 sample, 10 bobbin out of say 1000 bobbin. So, we will have certain limit of confidence. Okay. Now, if we test 100 bobbins out of 1000, then our confidence will be more. That means, the number of sample if we increase, the larger the sample, the more confidence we will get. So, that we will discuss. So, by sample analysis we can achieve two main objectives. So, sample analysis, by analyzing sample we cannot tell that it is a characteristics of the population, we cannot tell, but by sample analysis we can achieve two objectives. It has got two objectives. The first objective is that when we wish to confirm or reject that a change in anywhere had a real effect on some property, then we carry out significance test. So, for significance test we have to take the sample. Suppose we have done some experiment, suppose we have changed the twist, and we want to know the effect of twist on yarn strength. So, what do? We test the sample before changing the twist, we take sample and test the say strength before changing the twist, then after changing the twist again we take sample, and from these two sample we can at least tell that the change, whatever change has taken place, whether it is a real change or we can eliminate, we can avoid that effect. Okay. So, that is why that may be significant or may be insignificant. So, that significance test we can do by doing the sample analysis, that is the first objective, and the second objective is that to estimate. So, we cannot actually confidently tell the characteristics of the population, but we can estimate some characteristics of the population from the result of test on the sample. Just we can estimate. What is the estimation? From the sample result we can estimate the limits between which the population mean lie. So, that means suppose a population, suppose 1000 bobbins are there, it has got a strength of say 10. Okay. And 1000 bobbin, if we test the 1000 bobbin individually and we are getting say strength of 10 whatever unit. Now, from 1000 bobbin if we take sample of say 20 bobbin sample and we test the bobbins 20 bobbins, we may not reach, we may not get the value 10. How do we get the value 10? We cannot get the value 10. We can get value little maybe more than 10 or less than 10. Suppose we have got value 9.5. Now, what do you do with the 9.5? Can we tell that if we test 1000 bobbin and we will get 10? That we cannot do, because sample cannot tell exactly the value of the population, value of the result from the population, but by testing sample what we can do, we can guess, we can actually predict the mean of the population. mean of the population, we cannot pinpoint the population, exact population mean 10, we cannot pinpoint the 10 value, but we can predict the range. We can tell with certain confidence that the population mean is lying between 9 to 11 or lying between 9.5 to 10.5 or lying between say 9.8 to 10.2 like that. So, that range we can tell and with certain confidence, and this limit, this range or this limit is known as the confidence limit or confidence interval, and by sample analysis we can calculate this confidence interval. Confidence interval means it is not the value, it is a range, the range will tell us with certain confidence, it may be say 99% confidence, maybe 95% confidence, that certain confidence it will tell us that okay, the population mean will lie within this range. Okay. Now, to have sample analysis, we have to go for the sample distribution. So, sampling distribution we have to do, we cannot actually test all the data, all the throughout the population, as we have already discussed, we cannot test total population, we have to test the sample. Now, then what is sampling distribution? In population we have discussed, we have actually assumed that it is a normal distribution. Now, what is sampling distribution? In sampling distribution, what is there? We have to take a number of sample. Okay. So, take large number of sample randomly from the population. Okay. Now, let us see, suppose this is whole population, okay. This is population and it has got large number of data. Now, we cannot test all the data, all the samples. Now, we have to take the smaller sample. Now, and for each sample we are taking n number of data. Now, suppose first we are from the population we are picking n data. Okay. So, from n data we are getting some value mean. So, x 1. X 1 is the mean of the sample, first sample. Similarly, 2 n is there, here again x 2. This is the mean of the samples x 3. Now, these are the means of sample. Now, if we can plot again the distribution, the frequency distribution of this mean of the samples. Okay. Mean of samples, what we will get similar distribution. And this distribution is known as sample distribution. Okay. So, this is the normal distribution for population, okay. This is for sample, this is population. Okay. So, as we have discussed, so the take a large number of random samples, each of n individual. That means, this mean x 1, x 2, x 3 what we have discussed, that it is some average of n individual data. Okay. Take frequency distribution of means of each sample as we have discussed. This distribution is called sampling distribution. So, we must be very clear about the normal distribution of population and sampling distribution. Okay. And standard deviation of sampling distribution of mean is standard error of mean. So, that is in population, if we take individual data, all the individual data and take measure the standard deviation, so say 1000 data, 1000 bobbins were there, we have tested whole population, that is a standard deviation. Now, if we take the standard deviation of sampling distribution mean, then it is called standard error of the mean. Okay. It is not the this term, although it is a standard deviation of the mean, but its term is the standard error of the mean. Okay. Now, here standard error of mean we can calculate is that the standard deviation of population divided by under root n. So, we can come back again here, if we see this was the population, suppose we have taken this is sample 1, sample 2, sample 3, whatever may be, here n number of samples are there. Okay. Now, the standard deviation of mean of whole population. So, this is the standard deviation of whole population, and if we want to calculate the, so this is the value, mean value 1, this one is the mean value 2, okay, mean value 3, like that. Okay. So, this value consists of n data, the individual one value, one data, it consists of n data from the population. Okay. Each value, each data point, it is a average of n data. That is why as this n data are mixed together here, that is why here standard error of mean is under root n. Okay. This is the averaging out. Okay. The similar concept we use for that mixing up of the sliver, okay, and whatever in drop frame we sliver, we n number of sliver we mix, in that case we divide by under root number of sample, number of strand, this we will discuss. So, this is the same way. So, standard error of population, standard of mean is standard deviation of population divided by under root n. Okay. And this is the way of you can measure the standard deviation, and here we can see this is the standard. Okay, this is the sampling distribution. In the sampling distribution we do not use the standard deviation. In normal distribution what we have seen, we use plus minus 1 sigma, plus minus 2 sigma, plus minus 3 sigma, like that. Okay. That is the sigma is the standard deviation. Here we do not use that standard deviation, here we use in the term of not the standard deviation, in the term of standard error. Okay. So, this plus minus 1 standard error of the mean. Okay. So, error of mean, because this is a sampling distribution is the mean of samples. Okay. That is the difference. So, this is the say 1.96 in multiplied by standard of error, okay, like that. Now, impact of sample size. So, if we change the numbers as we have discussed, that say 10 or 20 samples, 20 samples per n is 20, 20 number of data per sample. Okay. So, if we change, keep on changing the number of sample, our data that is sampling distribution curve will get affected, will change. The spreading of sample distribution of mean depends on the number of data per sample. So, if we see this is the population, okay, the black color, this one is the dark blue color, it is a population. Now, if we take the sample out of that, say 10 sample per 10 data per sample, one sample 10 data, then this purple color or pink, this is the sampling distribution. The spreading will gradually be closer and closer. So, if you take more number of sample, so your spreading will be closer. That means, what does it mean? That means, your confidence is increasing, it is closer and closer, it is your confidence, you are increasing the confidence. When we will do the actual calculation, numerical we will do, we can see very clearly the how your confidence is changing with the number of sample. Okay. For the larger sample size, the spreading is smaller. So, if we take the larger sample size, the spreading will become smaller. The spreading decreases as the rate at the rate equal to under root n. That is that we know, that is, and this if we see the number of that sample size n, and this is the standard error of the mean, it decreases gradually with the number of sample, okay, that we have seen earlier. I think it is clear. Okay. Now we will go the step by step. So, stepwise how to calculate the, how to know the significance. Okay. So, steps for significance testing. So, our which is our first objective. As we have discussed, we have two objectives. One is to test the significance, whether there is any change or not by doing sampling, and second objective is to know the whether the it is a some confidence interval we try to calculate. So, that is we can estimate the characteristics of the population. What is the estimation? Estimation of the range. Okay. Now, let us see the first objective, to steps for significance testing. Now, this is the sampling distribution. Okay. Now, this central one is a nominal mean. So, we know this is our targeted mean, okay, this is our nominal mean. Okay. Now, after taking sample, what we have got, this one is the sample. So, this is the mean of the targeted mean of the population, suppose. Now, this one is the sample mean, and this difference in mean is expressed in terms of standard error. Earlier what we have seen in normal distribution, the difference was expressed in terms of the standard deviation, but in normal distribution it is, as we have mentioned, that it is a standard error, and there we have discussed plus minus 1 sigma, plus minus 2 sigma, like that. The one time of sigma, 2 times of sigma, here it is a t times of AC, t times of AC. So, t is the, we can get standard value from the table, this is the t distribution table. So, t we can indirectly calculate by the difference in mean divided by the standard of error. So, then how to calculate the t? To calculate the t value using the appropriate formula, we can calculate the t value. So, t value we can calculate, this t indicates the position of actual value, this is the actual value. As t increases, this will be moving away, when t decreases, this will move closer. So, t indicates the position of actual value, that is sample mean, as compared to the idealized value, that is the nominal mean. That is how we can calculate. Now, the steps, the third step is that if d is higher than the standard value, so this d value, if it is higher, then the difference is significant. So, d is known, okay. From d we cannot compare, d is we have to compare in terms of t value. So, t is calculated, that d divided by AC. So, then the difference is significant and vice versa. Okay. standard error is calculated based on the actual data and is unique for a particular sample. So, for any sampling distribution the standard error will be unique. Okay. So, first we have to calculate the standard error and then we have to calculate the t value. This t value, so d is known because our nominal value is known, our sample mean is known, we have calculated, and then the standard error we can calculate using the formula which is unique for any sampling distribution, and then d divided by standard error we have calculated the t value. So, this t value which we have calculated here based on the sampling mean, then we have to compare with the standard t table, and this t table we can calculate compare. Now, let us see. So, this if the t value calculated t value is more than the standard t value, then the difference is significant. Now, try to see here. These are the t value t table okay, for different degree of freedom, for 1 degree of freedom and at different confidence level. So, it starts with 60% confidence level, 70%, 80, 85. So, typically we use two different types of confidence level, one is 95% confidence level, another is 99% confidence level. Okay. This is the most commonly used. So, 99% confidence level, and depending on the number of data. So, typically number of data degree of freedom is number of the n minus 1. So, if we have say 20 data, 20, the degree of freedom will be say 19. So, you can check. Okay. So, here suppose we have say 24 data, one example suppose is 24 data, and this we have calculated whatever t value we have calculated. So, 23 is degree of freedom, then we can compare with these two value 2.069 and 2.808. Now, if our t value is say 2 or 1.5 calculated t value, then we can very well say that the whatever difference they are not significant at both 95% significance level and 99% significance level. And if these are this value t value we are getting say 3, then this t value is more than this 2. So, that then we can say whatever difference is there, it is actually there is a real difference is there, it is a significant difference is there, and if the data is in between these two, then we can tell okay, there is little evidence is there, but its actual difference is not there, because at 99% confidence level this is insignificant, that we can we may not take any action, we may not reject the sample. Okay. We can tell that statistically it is not significant. Okay. And second objective is that to estimate the characteristics of the population, to estimate the range. A sample can give some information about the whole population, but it cannot give complete information, like it cannot tell this is the mean. Hence, the mean and standard deviation from sample will only be estimates of the population, these are the estimates. So, if we take the sample and sample mean we have calculated or standard deviation we have calculated, this will give us some estimates. Okay. And we can express the estimate as range, we can tell in this range which within which the population is expected to lie, okay, at certain degree of confidence. Okay. That we can tell at 99% confidence level, this is the range. Okay. I can tell at with a 99% confidence that the range, that population mean will lie in between that. That means, suppose we test any data, sample data, and we have got the estimate, the confidence range of say 10 to 12 okay, at the 99% confidence level. That means, out of 100 data, out of 100 99 times the probability is that the confidence that population mean also will lie within that range. This range is known as confidence interval. Okay. Now, let us see what are the tools we use to understand the significance test, do the significance test, or to know the whether there is any real difference is there or not. Okay. So, first is the Ttest. Okay. Ttest can be actually applied if we want to test the difference between the mean or difference between the variability. So, suppose two samples are there. Okay. Sample 1 has got standard deviation of say 5 and sample 2 of standard deviation of say 6. So, this standard the variability whether 5 and 6 is this difference really there is a significant difference or not, that we can test variability, and also we can test the mean. So, one sample the strength, suppose mean strength is say 50, another is 52. So, whether this 50 and 52 is the difference is really significant difference or not, that we can verify by Ttest. Okay. And what is that? So, Ttest T value we have seen earlier. So, T we can difference, D is the difference. What is that mean? T difference means nominal mean minus sample mean. This is under modulus because it may be negative or positive. We will always take the positive value. It may be on the left side or right side. So, T is equal to this D value, D is nothing but nominal mean minus sample mean divided by the standard error. Okay. So, that T we have calculated x 1 minus x 2 by standard of error. Okay. Next is that Ftest. Ftest is also done for significance test, but here Ftest is only used for the significant difference between the variability. It is not, it does not take care of the mean value. So, there are in any sample there are two characteristics, one is the mean, another is the variability, standard deviation or coefficient of variation. Okay. The Ftest is, it takes care of only variability, that significant difference between the variability. And what is variance? Variance is the square of standard deviation, and F is nothing but the ratio of the variability, ratio of the variance. Okay. Now, how to calculate F? It is called variance ratio. Now, one should be very careful, one should it is that the variance F value is always more than 1. We have two data, like one is variance 1, another is variance 2, but we should know that which one is more, whether the sample 1 variation is more or sample 2's variation is more. The higher variation will always go in the numerator. So, variance expected to be greater, okay, and then variance expected to be smaller. So, this ratio, so F value, to have F value more than 1, that we can have. So, we have say two variance value F V1 and V2, these are the variance value. We must know that which one is more, and higher variance value we always call it as V1. It is a basically that is the normal understanding. Okay. It is a convention that we always take V1 as the higher value, which goes into the numerator. Okay. So, V1 is higher than V 2. So, that means what will be the f value? F is V 1 by V 2. So, this is the f value. Now, we have calculated. So, two standard deviation S D 1 and S D 2. S D 1 we have squared that will become S D V 1 and then S D 2, and depending on the which one is high we will put the value either V 1 or V 2. Okay. And then the calculated f value is compared with the standard table, standard f table. Okay. Here the standard f table it is given. Now, we can see here the standard step, it is for 1% significant level, that means 99% confidence interval. Okay, level. Now, in x this is the in horizontal, this row shows the degree of freedom for V 1. Okay. That means, that number of sample minus 1, it is for always this side is for higher value V 1 and vertical is this is for V 2, that is for denominator value. Okay. So, whatever, and accordingly we can get the value. Okay. Similarly, for 95% significance level, and if we compare this value with the actually calculated value, and if this calculated value is more than the tabled value, then we can tell that the variability is significant. Okay. So, this is the Ftest value, and third one is that it is a chi-square technique. In chi-square, it is that this is the method which is used when there is no prior knowledge of the distribution of the test value. So, in earlier cases the Ttest and the Ftest, we know it is a normal distribution and all that, and here if we do not have any information, if we do not know the standard deviation value, nothing is known, in that case we can use the chi-square technique. Chi-square table is there, okay, that we can use. So, this is the observed value O and then expected value. So, suppose one some test result we expect it has to be 10, okay, and we have observed that the value has become 9. Okay. Now, we want to know, and we do not have any other data, we do not have standard deviation, we cannot calculate the standard error, okay. Now, we cannot calculate it. So, in that case what we do? So, you simply use the observed value 10. So, observed value say 10 and expected value say 15, whatever 15. So, that we use and we can calculate the chi-square value, and this value we can from the table chi-square table we can compare, and then we can tell that whether the difference is really significant or not. Okay. So, these are the three techniques we can use for significance test. Okay. Now, another system, another technique which is used in textile industry very frequently, which is called control chart, okay. And it is very convenient, we do not have to calculate on the regular basis. Based on the experience we can form the control chart, and it is the visually one can say whether the total process is under control or not, the system is running perfectly or not, that we can guess from the by looking at the control chart. And it is not the in a particular day, even for throughout the month we can see that what is happening in the production in the data. Okay. It is a convenient method of presenting routine testing data in a readily understandable form. So, one can immediately tell looking at the okay, your process is going fine or not. Okay. So, this is the control chart, where the mean is known, that is the say targeted value, it is the nominal value, it is a fixed, that is our target. Okay. Now, the upper limit, there are two types of limits are there. One is that warning limit, another is called action limit. The warning limit, it depends on the industry to industry, at what level they would like to have. So, if we fix, say warning limit will be plus minus 2 sigma, okay, plus minus 2 sigma, and it is not fixed. We can have, depending, if our requirement is say more stringent, then we can set plus minus 1 or whatever limit. Okay. Now, this is the upper warning limit and lower warning limit, plus minus 2 sigma, and plus minus 3 sigma is the action limit. So, what does warning limit mean? Warning limit means we do not have to take immediate action. Let us take example. So, this is the mean value. Suppose we are trying to produce a yarn with say 30s count. Okay. This is the count chart, count control chart with the 30s count is there, and this sigma, we do not know the sigma, that is the expected sigma, expected standard deviation, that is from our experience. So, we from say last 1 year data, last 2 year data, we came to know we are getting say sigma of say 0.5. Okay. Now, this is say 30s count, and plus 2 sigma means it will become 31 and 29. So, 31 count and 29 count, that, and plus 3 sigma we can immediately. So, 31 count and 29 count, whatever, so that means our allowable count is say 29 to 31. Now, it depends on us, okay, whether should we allow it or not, should we set warning limit from 29 to 31, or we would like to have from 29.5 to 30.5. So, that depending on that and depending on the variability we can calculate, and one must be very careful, we cannot unnecessarily make the limit stringent, because we will not be able to achieve. So, in that case rejection will be too high and unnecessary we will take action. So, depending on the allowable achievable standard deviation we set, that is why in normal practice it is a plus minus 2 sigma limit is the normal industry they follow, that within plus minus 2 sigma limit, that is warning limit. So, do not take action, and then plus minus 3 sigma limit, if it crosses then you have to take immediate action. Suppose we are in plus minus 2 sigma limit, it is a 31 to 29 to 31. Okay. In that case, if we start taking action, then it will be too much. So, then you cannot actually run your machine, but if you start allowing more than that, then you will start getting complaint. So, because it's you can control that one. So, that is how we typically plus minus 3 sigma limit, as we have seen, it is typically 99.9% data will be always there. So, if it goes beyond that, then we have to, and if it repeats, then you have to say it crosses the control limit. If it goes once in say 1000 time or something, then we can say it is by chance, but if that value repeats, then you have to immediately take action. Okay. So, the control limits are chosen on the basis of experience and previous trend. We cannot randomly select. So, that is, as I have mentioned, if we select closer limit, then unnecessarily we will have to take action, which may not be required, and also there is no solution, because our machine, suppose a particular machine can produce standard deviation at certain limit. So, that is the limitation. If we try to achieve better than that, it is not possible. So, unnecessary we cannot. That is why based on the experience and previous trends we we have to select the limits. If the data fall outside the warning limit, we should not take immediate action. Immediate action is not required, because then there will be large number of data. So, that in that case only thing one has to be warned that okay, you take proper action, you like for yarn count variation, whatever the back process requirement, one can give warning, like for yarn say count variation, it is crossing the warning limit, then one can take action in the carding, blow room or draw frame. So, that count variation is actually minimized, but only warning is given. But if it is crossing the limit, this one upper action limit, in that case this is the in here, if it is crossing, then we can take action. Now, if you see, this is the yarn count data throughout the month, for throughout the month this is the count data. So, in at different days we are taking count. So, mean count of particular date or a particular lot. Okay. So, day 1 this is the count, day 2 count, day 3, day 4, day 5, in that way different days we are counting, and at certain date we found that this is the say yarn count in any, that means it is a lower value, that means it is giving coarser value, it is okay. Now, this coarser one can always try to analyze why is it coming coarser, and immediately it has action has been taken, it has again come back to normal position, and suddenly at certain date, particular day, it has been observed that this is coming finer. So, immediately action has been taken, but the warning has given, warning was given, but they have taken some precaution. It is not action, it is a precaution they have taken, again it has come back in that way. So, this will go across, but once it is crossing this limit, then immediately action has to be there. You can stop the machine, you can recheck, you can even send back the draw frame and redo the all this reprocess all this material, and finally we will get the correct result. Okay. So, this all this data one can take action, and this is called the upper action limit. Okay. So, and the advantage of this is that this picture, if I go to that shed or if I go to the laboratory, I can tell that okay, throughout the month what had happened, and that how many times this has crossed the warning limit, that also will be given, will show that it is the performance of that particular process, how many times it is crossing the one. Ideally it should be within this warning limit. Okay. And if it crosses repeatedly the action limit, then proper setting of the machine, proper selection of the raw material, everything has to be done. Okay. And we will stop here, and in next class we will do all the numericals based on the practical examples. Okay. Thank you.